Hello friends, welcome to Risingpearl.com. Today we are talking about series 12 where we are learning a great deal on areas related to circles. This is webisode number 4, and friends, today we are going to focus on area of a sector of a circle. So let's find out what do we mean by area of a sector of a circle. Let's quickly refresh our memory of what is a sector of a circle. So we have drawn ourselves a circle. Let's call the center O. I have taken randomly any 2 points on the circle. It doesn't have to be these points. You can take any 2 points as long as they are on the circle. That is all the only thing that we want to make sure. Now, so whenever we take any 2 points on a circle, you get an arc, part of the circle which is in between the 2 points. So this we have seen in our earlier grades. This is called minor arc, because there are, when you take any 2 points, it divides the circle into 2 parts. One is AB and then the other part of the circle is BA. So the smaller one is minor arc, and the bigger part of the circle, which is BA, which is this one, that will be the major arc. Right? Now, if we join OA and OB, that means if we draw OA and OB, then what we see is that now our circle, the whole circle is basically divided into 2 parts. So one is this part and the other one is this part, right? So the part of the circle, the region, portion or part of the circle in between the arc AB and the 2 radius, if this is R, this is R, so the part of the circle between the arc and the 2 radii joining the center to the end points of the arc, we call that sector. So that is what we mean by sector. And as you can see, we have 2 sectors. So the one that corresponds to minor arc, we call that, as you can imagine, that is called minor sector. And the one that corresponds to major arc would be then naturally called as major sector. So what we did, all we did was we have taken 2 points on a circle and we have joined the center to the end points of those of that arc, right? Or joined that with the 2 points on the circle, and we have got a minor sector and a major sector. Now going forward, so let's highlight one of the portions. So here I have highlighted the minor sector by blue, and then the major sector I have left it unhighlighted. Now, so what we note, friends, is that when we say area of a sector of a circle going forward, we are going to be referring to this part which is highlighted in blue, or part 1. That is, we are going to be referring to minor sector. It is important that from this point forward in this webisode and for the rest of, generally speaking, whenever we talk about sector, we are referring to the minor sector, not the major sector. Something to keep in mind as we continue to learn more and more things in this webisode and in this series and going forward, right? Now I'm going to ask you a very simple question. Say I tell you cost of 1 pen, like writing pen. Let us say this costs X amount. X could be any amount. And then I ask you, so can you find out the cost of, say, 5 pens, 5 such pens? So you will think for a moment and you will say, obviously it is very straightforward. If cost of 1 pen is X, then the cost of 5 pens is quite simply 5 times the cost of 1 pen, which is X. And I would totally agree, this is the right answer. So this is the right answer. So what does this question even mean? So over the years we have come to know about this, this is different names, but one of them is a unitary method. If you find out how much is the cost of 1 unit, we can easily find out the cost of 5 units, right? Now, you will see how this very simple concept is related to what we are going to just talk about in a moment. So here what I have done is I have drawn a straight line. Now you can draw any straight line of your choice. It doesn't have to be this one. As long as you draw any straight line, that will work. So what we are going to do, we are going to pick one of the ends. So either this end or this end, again doesn't matter. You choose one of the ends of your straight line. So in this case, I'm going to take this end, and what I'm going to do is I'm going to rotate this line around this pen in this fashion. Meaning I'm going to rotate this straight line around this point going out like this. So how will it look like? So it will look something like this. So if you notice here, it has moved a little bit. And what I'm doing is I'm showing the earlier position by the dotted line, and the new position is a solid line. So let us continue to do this. So let's move it out a little bit more. And as you see, as I'm rotating this out, we are getting a certain shape or a figure, right? So here at this point, I have taken the line, I have rotated out all the way till it has come back to its original position. I'm doing that once, right? I'm making one full rotation. So what I do notice is that at this point, I have actually gotten myself a circle. So if I rotate it out a little bit, and I keep doing that till I get back, so I have got myself a whole circle. In other words, so I started from 0 degrees and I went all the way till 360 degrees. We know that if you make one full round, you basically cover 360 degrees. So I moved from 0 degrees to 360 degrees, right? Now, so what is that we are trying to get at here? The point is, as I move from 0 to 360 degree, I am basically drawing a circle. If I think about, so now once I have the whole circle, so how much is the amount of space which is enclosed? I have gotten myself a whole circle. So in other words, if I have 360 degrees, then I get area which is equal to pi r square. From our earlier webisodes, we know that area of a circle is pi r square. So if I go, so when I had only my straight line, there was no area. It was only a straight line, right? So there was no area. Now what is happening is, as I am going from 0 to 360 degrees, when I am at 360 degrees, I am having a full circle. And that entire circle has an area of 360, it's pi r square, where r is the length of this line, right? This line is r. So for 360 degrees, I have an area equal to pi r square. So if I would have gone only 1 degree, what would have been the area? Area is represented by A. Well, like the way we were talking about earlier in the unitary method. So for 360 degrees, if I get pi r square, so if I go 1 degree, I would have gotten pi r square divided by 360 degrees, right? And now if I go a certain amount, so let's say now I don't go all the way, but if I go from here to, let's say, just here, theta degrees, then how much is the amount of area that I would have covered? So for 360 degrees, it is pi r square. For 1 degree, I would have covered this much. So for theta degrees, which is anything which is less than, which is in between 0 and 360, so it will be basically the area for 1 degree, which is pi r square, divided by 360, this times theta. Because we just saw if the cost of 1 pen is x, cost of 5 pens is 5 times that. So if 1 degree basically covered this much area, right, then theta degrees will cover this times theta. So in other words, friends, now if we just, clean this up. So if I draw a sector, so I start here, and if I draw a sector which is theta, let's say this angle subtended by this arc at the center is theta. That means if this angle is theta, then the area which is actually covered by this part which is enclosed in here will be pi r squared, the whole area of a circle, divided by 360 times theta. So this is the amount. This is going to be the area of a sector of a circle. So it depends on r, which is the radius, and depends on the angle subtended by the arc at the center. So this is very, very important, friends, because going forward, whenever we talk about area of a sector of a circle, that will mean that we are trying to find out the area which is enclosed over here, which is this part, right? And the amount, the value of how much this space is going to be given by pi r squared by 360 times theta, where r is the radius of the circle and theta is the angle subtended by the arc at the center.